Hey, hi, Rajat this side. Welcome to my YouTube channel. Today we will discuss all the four problem answers in today's LeetCode Weekly Contest 464. So let's start with the first problem. So it says you are given integer array n. Your task is to compute the GCD of these two values, sum odd and sum even. Sum odd means the sum of first and odd numbers, and sum even means the sum of first and even numbers, right? And we have to turn the GCD of these two numbers. Yeah, let's see how we can approach this problem. So if you notice, the sum odd means the sum of first and odd numbers, right? 1, 3, 5, 7 and so on. And the sum even means the sum of first and even numbers, right? 2, 4, 6, 8 and so on. So the sum of first and odd numbers is n square, like you can derive it. And the sum of first and even numbers is n plus 1, right? So n plus 1 means n square plus n, right? So now we have to find the GCD of this number and this number. So see, n is common among these two numbers, right? So GCD of n square comma n square plus n, like you can take n common, it would be n into GCD of n comma n plus 1, right? And we know that GCD of two consecutive numbers is always 1, right? So your answer is n itself. So the answer of this problem is n itself. So if you look at the code of this problem, I'm just returning n because n is my answer, right? So yeah, let's see the second problem now. This is the second problem asked in today's contest. So it says you are given an integer array nums and integer k. Your task is to determine whether it is possible to partition all the elements of the given array nums into one or more groups such that each group contains exactly k distinct element and each element of the num must be assigned to exactly one group. Alright, and return true if such partitions is possible, otherwise return false, right? So yeah, let's see how we can approach this problem. In the second problem, it says each groups contains exactly k distinct element, right? So if each group contains exactly k distinct element, it means that your total number must be divisible by k, right? So first check if n is divisible by k or not. If it is not divisible by k, then you cannot do the partition, right? And so just return false. If it is divisible, then the number of groups are exactly n divided by k. So these many number of groups which you can create, right? So let's say this is I'll call it G. So there are G number of groups, right? There are G number of groups, 1, 2, 3, G, right? So these many numbers of groups possible, and it says each group contains exactly k distinct elements, right? So and each element in the given nums must be assigned to exactly one group. So that we already so taken care. So now if you notice here, let's say so this is a given array, right? Let's say there is a number whose frequency is, the maximum frequency of a number is f, right? And let's say this f is greater than g. What it means, we know that in any group we cannot duplicate the number, we can keep a number single time, right? If f is greater than g, it means that there would be at least one group where this number would be repeated, right? So let's say there is a given number x whose frequency is f, the max frequency of a any number is f, and that f is greater than g, means that there would be definitely for sure that at least one group would contain a duplicate of this number x and x, right? So in that case, so if that's the case, like you cannot do the partition, your answer would be false. You can do partition only when the max frequency of a number is, max frequency f max is less than or equals to g, right? So yeah, so the idea of this problem is to find the maximum. So first check if your n is divisible by k or not. If it is not divisible, return false. If it is divisible, your number of groups would be n divided by k. Just check the maximum frequency of any number is at least g, right? If the max frequency is z, then like you can do the partition, so return true, otherwise return false, right? So yeah, let's see how we can write code for it. This is the code of second problem. So n is the size of the given array. So I first check if n is divisible by k or not. If it is not divisible by k, return false, right? If it is divisible by k, so like we can get the number of groups which we can create. So number of groups is n divided by k. Now I store the frequency of each number in an unordered map, right? So this here is I store the frequency. Now I found the maximum frequency of any number possible. So I iterate through this unordered map and I calculated the maximum frequency. Maximum frequency equals to max frequency comma it dot second. This is the frequency of that number. So just check if the maximum frequency is less than or equals to the given number of groups possible. If your max frequency is less than or equal to groups, it means we can create the partition, we can do the partition. So it would be true, otherwise false. So yeah, this is all about the code of second problem. Now let's look at the third problem. In the third problem, it says you are given an integer array nums, and for any index I, you can jump to another index j under the following rules. Jump to index j where j is greater than I means on a right side, and this jump is allowed only if the right side number is smaller than the current number. Means you can jump to the right side to the smaller numbers, and vice versa, you can jump to the left side to the greater numbers, right? You can jump to those numbers whose value is greater than the current number on a left side, and on a right side those numbers should be smaller than the current number. Now for each index I, you have to find out the maximum value in the given nums that can be reached by the following any sequence of valid jumps. You can do any number of valid jumps, and ultimately you have to find out the maximum value which you can reach if you start your jump steps from the index I, right? So yeah, so in the first test case for 2, 1, 3, your answer is 2, 2 and 3. Now for I equals to 0, it says no jump increases the value. That is true. Now for I equals to 1, you can move to the left side. So it says you can move to the left side only if the number is greater than current number. So yeah, here you can move jump to the left index 0, right? Because that number is greater than 1. So yeah, your answer is 2 here. Now for 3, you cannot jump on the right side because there is no number, and on the left side you can only jump if the number is greater than current number, but there is no number which is greater than 3, so you cannot do any valid jumps. So your answer is 3 itself, right? So 2, 2 and 3. Yeah. Let's see how we can approach this problem. In the third problem, it says we can jump to the left side to the number which is greater than, let's say this is my current number c, which is greater than c, and if you want to move on the right side, that number should be lesser than c, right? Less than c. And we have to find out the so we have to return the answer where answer of I is the maximum value reachable, right? So if you notice here, see, if you are jumping on a right side, the number is smaller than c, right? So will it help you to find the maximum reachable value? May or may not. That is because, let's say this is my current number 5, right? If you want to move on a right side, that means that number is definitely smaller than 5. Let's say this number is something like 3, right? But see, if you are just doing this move, then it is not optimal, right? The reachable value is 3, which is lesser than 5. So why should I do this jump? We should do this jump only if, let's say there is a number in between whose value is 10. So you move from 5 to 3, then 3 to 10. Then this is a then this jump would be considered as an optimal jump, because you move to the immediate next smaller number, but after that you move to the larger number, right? So this is an optimal move. So just keep this point in mind, that there may be, so it's not like your answer will always be maximum when you jump on a left side. So I just wanted to clear that. So it may seem that always jump on a left side because the left side number will always be greater than my current number, but that is not true. If there is a number like 5, 10 and 3, you can do this jump, 5 to 3, then 3 to 10. So you have to consider both the cases, both left and right jump, right? So that was one point. Now since this is kind of a like we don't know that which number to jump on a left side and which number to jump on a right side, right? So what I did, I first calculated the prefix and suffix array. So I created a array called prefix max, right? So prefix max so prefix max of I would essentially tell you the maximum number from index 0 to I, right? And similarly I calculated suffix mean, and suffix mean of I will tell you the minimum number from index I till n minus 1, right? Because if you notice here, like we can jump on a right side to the smaller number and we can jump on a left side to the larger number. That is why for large number I calculated maximum frequency, and for right side I calculated the minimum frequency, right? So once you calculated the prefix and suffix array, just start from start calculating your answer from the right side. See, for the last number you can only jump to the left side, right? Because there is no right number. So what will be your answer? Your answer of n minus 1, the last number will be the maximum among all the numbers from index 0 to n minus 1, right? So your answer of n minus 1 is prefix max of n minus 1, right? Because you can only jump on a left side, right? Now let's consider at any general index I, right? Now you want to calculate for any index I, right? So as discussed earlier, it may be possible that you do on a left side to get the maximum reachable destination, or you move to the right side to get the maximum reachable destination, right? So let's consider the first case. You jump on a left side. In that case situation, your answer of I would be prefix max of I, right? So this is the condition when you jump on a left side, left jump, right? Now the second condition, the second way could be to jump on a right side. So just notice, you can jump on a right side, like you want to jump on a right side, right? So just check the maximum among the number from 0 to index I, prefix max of, you can jump on a right side only if your prefix max of I is greater than suffix mean of I plus 1, right? You can jump on a right side only if your prefix max, the maximum among from 0 to I, is greater than the suffix mean of I plus 1. Why is that? Because let's say this is my I, let's say this is my number, let's say this is my number 2, right? And on a right side there are some number, the max number is the mean number is, let's say, 10, right? So if the mean number is 10, means the number are 10, 11 or 12 or something. You cannot directly jump to these numbers, right? Because in the problem it says that you can jump on a right side only if the number is smaller, so you can not jump directly. Instead, let's say there is a number on a left side which is, let's say, 15. Now you can do this jump. You can jump from 2 to 15 first, and then from 15 to any of these numbers, right? That is why I first found what is the prefix max. The prefix max is here 15, which is greater than the suffix mean. Suffix mean is the minimum among the right side. So like I hope you understand why I check the prefix max and suffix mean, right? Because we can do these kind of jump also, 2 to 15 and then 15 to 12, right? So yeah. like if this condition holds true, means you can do a valid right jump, right? In that situation, your answer would be, your answer of I, just update your answer, is maximum of answer of I, comma, answer of I plus 1, right? Because I have since you are going from the right side, if you are at I, means that your answer of I plus 1 is already calculated, so just update your answer, that's it, right? So yeah, I mean, so if you note down by yourself, you'd understand this problem is not that hard, right? So yeah, this is all about the explanation part. Now let's look at the code. This is the code of third problem. So as discussed in the explanation part, I calculated prefix, suffix. This is my answer. So prefix means prefix max, suffix means suffix max. Suffix mean, and this is my answer. So this is how I calculated the prefix max. Your prefix 0 is nums of 0, and for I equals to 1 to n, your prefix of I equal to max of prefix of I minus 1, comma, nums of I. Similarly for suffix, I started calculated from the right side. So suffix of n minus 1 is nums of n minus 1, and from index n minus 2 to 0, your suffix of I equals to minimum of suffix of I plus 1, comma, nums of I. So this calculated the minimum on a right side, and this calculated the maximum on a left side. So once you did that, you start iterating from the right side. So answer of n minus 1 is equal to prefix of n minus 1, because you can only move to the left side, right? And then for index I equals to n minus 2, I greater than 0, I minus minus, I mean for all the numbers which is not the last number, your answer is equals to initially prefix of n. I means the left jump, and as discussed, you can only move to the right jump only if your prefix of I is greater than suffix of I plus 1. Like please check out the explanation part. There I have discussed why this condition is required to do a right jump. So if you can do a right jump, your answer of I, just update your answer. Your answer of I equal to max of answer of I, comma, answer of I plus 1 to do a right jump. So yeah, this is all about the code of third problem. Now let's look at the fourth problem. This is the fourth problem asked in today's contest. So it says you are given an endless straight line, right? And that has some robots and walls on it, right? And so you are given robots array, distance array, and walls, right? So robots of I is the position where the ith robot is placed. Distance of I is the maximum distance the ith robot bullet can travel. So like if the robot at position I shoots the bullet, it will go till the maximum distance of I, and there are some walls present on that given straight line, right? So every robot has one bullet, and that can either fire on a left side or on a right side, and that will go at most distance of I meters, right? And a bullet destroys every wall in its path that lies within the range. So once the fire the bullet, it will keep on destroying all the walls that comes in that path, right? So robots are fixed obstacles. So if a bullet hits a robot, it will immediately stop and won't continue further. And you have to find out the maximum number of unique walls that can be destroyed by the robot. So let's say there are a number of robots. If each of them start firing either on a left side or on a right side, there would be some walls break, right? So we have to find out the optimal like the maximum unique number of walls that can be destroyed by all the robots, right? So this is a kind of, I would say, binary search plus some ad hoc intuition problem. So let's see how we can approach this. In the fourth problem, we are given a straight line, right? So this is an infinite straight line. So these are few of the robots placed, and these are the walls present, right? So and each of the robots can fire either on a left side or on a right side, right? And we don't know which one would give you the optimal answer. So this indicates that we can solve this problem using dynamic programming. So we will create a DP array, DP of n and 2, right? So DP of I 0 will tell you what is the maximum wall destroyed by robots from 0 till index I, robots from 0 till index I, such that ith robot shoots I mean ith robot fires bullet on left side and dp of I1 is the maximum bullet exactly same, but it fires on a right side. So this is the definition of my dp of I0 and dp of I1, right? And let's see each robot what where they can fire exactly. So let's say I am configuring this robot, right? We know that we are given distance of I is the maximum distance till your bullet can destroy the walls, right? And we know that let's say this position is x, this distance is d. So on a left side it can fire from, like, it can destroy all the walls that is present in the range of x minus d till x, right? And on a right side it can destroy all the walls that lies from the range x comma x plus t, right? So these two are the ranges, but the only like tricky part is that if you hit a robot, your bullet will stop immediately, right? So along with this too, we also have to consider if there is a robot in between in that range. If it would be so let's say this is my range, right? X minus d to x. But let's say there is a robot that present at index x minus something, let's say d plus p or something. Means, so what I want to say, let's say this robot is present in between this range. In that situation, your updated range would be this x minus, let's say this is k, x minus k till x. So the maximum of x minus d comma x minus k, right, where the robot is present. So this is kind of implementation, and so I hope you understand how to solve this problem. And for other dp, let's say dp of I, so let's say you want to calculate dp of I0. In that situation, your answer would be number of walls that is destroyed by my bullet on a, like if I fire on a left side, let's say that bullet broken is KL. That would be KL plus maximum of dp of I minus 1 0 comma dp of I minus 1 1, the maximum among these two. And similarly dp of I1, like you can calculate dp of I1, that would be k right plus max of this. So it's a kind of a combination of dp, binary search and all these, right? Unfortunately I don't have a code for it right now. I'm still like writing the code for it. So like I hope you understand how to approach at least. But if you need like if you want to so understand the solution completely, please write a comment. I'll write a separate video for this fourth problem. This is a very interesting problem, by the way. So yeah, this is all about today's contest. So if you find the video helpful, please like, share and subscribe to my channel. Thanks for watching. Have a nice day.